Hey Chem Kids, Campbell here. In our next video on bond, chemical bond, we're going to talk about Lewis structures, this time for covalent compounds. Now, remember, a covalent bond is the sharing of electrons. So when we draw our Lewis structures, we're going to show the sharing of the electrons. Now remember, it's all about 8, right? Everything's about 8. And in order to be stable, an element needs 8 valence electrons. So they're going to have to share so that they can have 8. Now, the only element that will not have 8 is hydrogen. Hydrogen can only have 2. But once it has 2, it's happy. So let's take a look at the steps for drawing Lewis structures for covalent compounds. So we're going to use this, and remember, a covalent compound is a molecule, which is a molecular compound, it's a molecular nomenclature, right? This would be dihydrogen sulfide. So step 1 is we're going to have to add up the total number of valence electrons in the molecule. So we go to the periodic table and we find hydrogen, and hydrogen has 1 valence electron. And we're going to have to multiply by the number of atoms if there's more than 1. So for hydrogen, we have our 1 valence electron because it's in that very first column. But in the chemical formula, there are 2 hydrogens. So we need to multiply by 2, and that means that hydrogen is contributing 2 electrons to the number of valence electrons in this compound. Sulfur is on the right side. It has 6 valence electrons because it's in column 6. There's only 1 sulfur, so that means it contributes a total of 6. So now we add these together, and our total valence electrons in the molecule is 8. It's the magic number! All right, so first step, find out how many valence electrons there are total in your element by looking at the periodic table. Next, you have to identify which atom is the central atom because we're going to draw a molecular skeleton. Now, how do you figure out the central atom? Well, it's the atom with the fewest atoms, but it's never hydrogen. So in this case, it's our sulfur. Sulfur's our central atom. Now, we're going to write the other atoms around the central atom, so we're going to put a hydrogen on both sides of our sulfur. And of course, I put them in a line, but you could put them as like an L shape. Totally cool, as long as they're around the sulfur. Next thing we're going to do, we're going to put 2 electrons between each of the atoms because a single bond has 2 electrons. So we're going to take a total of 4 of our dots, and we're going to put them on either side of the sulfur, in between hydrogen and sulfur on both sides. Now these are called bonding pairs. Now we're going to distribute the rest of our valence electrons. So remember, we had a total of 8. We just used 4. So we have 4 left. Now normally you start on the outer atoms and start putting in all the remaining valence electrons. But if there's hydrogen, hydrogen can only have 2. So once it's in a bonding pair, it's done. So we're going to take our remaining 4 electrons and put them around our central atom sulfur, just like that. Now notice that sulfur has 8 valence electrons. Yay, 8, it's happy, and hydrogen has 2, which makes hydrogen happy. So everybody's happy, and we have a stable compound. So this is the Lewis structure for dihydrogen sulfide. So let's go over a couple little name things. So these guys, right, the ones between the atoms are called bonding pairs, and in this case we have 2 pairs of electrons in bonds. And these guys are all by themselves. They're not between atoms, and those are non-bonding electrons, which we call lone pairs. You're going to need to know that for our next video. All right, now one thing about bonding pairs is you can also represent them by using a dash. So anytime you see a dash, it represents 2 electrons. So instead of dots, you can use dashes, but just for the bonding pairs, not for the lone pairs. All right, let's do another example. Phosphorus trifluoride. All right, so we're going to count our valence electrons. So go to your periodic table and find phosphorus and fluorine. Well, phosphorus is in column 5, so that means it has 5 valence electrons. There's only 1 phosphorus in the formula, so that means 5 times 1 is 5. The fluorine is in column 7, it has 7 valence electrons, and there are 3 of it. So we multiply by 3 and we get 21. So we have a total of 26 valence electrons. That means we're going to be writing 27 dots. All right, step 2, find the central atom, which would be the phosphorus because it's the one I have the least amount, and put the other atoms around it. So they're my fluorines. And this guy could have been on the top. That's totally cool. But just distribute them around the phosphorus. Next, we're going to put in our bonding pairs. So we're going to put in 2 dots between each of the atoms here. So a pair of dots between phosphorus and fluorine here, here, and here. So we've just used 1, 2, 3, 4, 5, 6 valence electrons out of our 26, which means we have 20 left to go. That means 20 more dots. All right, so now we just have to distribute those 20 remaining electrons. And of course, we need to make sure that all of them, all 4 atoms, because none of them are hydrogen, have a full octet. So they have a total of 8 dots around them. All right, let's start with fluorine. We got 20 to go, so let's start putting dots down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18! Well, my fluorines are done, right? Because if I look at each of them, they all have 8. I have 2 left, but that's good, right? Because I need phosphorus. Doesn't have his full octet yet. He needs 2 more. So 1, 2. And there's 20. And now if I went back and I counted all of my dots, I should see that there are 26. And that's how many valence electrons I had when I counted in the beginning. So this is my Lewis structure for phosphorus trifluoride. And all atoms have an octet. They all have 8. Whether they're sharing them or not, it still counts. And so, yay, success! Now, these have what are called single bonds. But sometimes we're going to have what's called a multiple bond. And a multiple bond is where we have more than 2 electrons being shared. So our single covalent bond is just a pair of electrons, right? Anytime we have a bonding pair, it's 2. But sometimes we'll have multiple bonds. And we could have a double bond. A double bond has 2 pairs of electrons. A good example of that is oxygen. When oxygen binds to itself, it has a double bond. So these would be, right, each dash represents 2, and there are 2 dashes, so that's 4. So the double line is a double bond, and it means that it's sharing 4 electrons. A triple bond has 3 pairs of electrons. So we're going to see it as 3 dashes, and a good example of that is nitrogen. When it binds to itself, it actually has 3 bonds, which is a triple bond. Remember that each dash represents 2 electrons, so 3 times 2 is 6. So I have 6 electrons in a triple bond. So let's do some. Let's see, what does that look like if I have to have these multiple bonds in between? So let's take a look at carbon dioxide, and we'll look at how did we get that triple bond between nitrogen. But to do this, I think it's better that we go to the whiteboard. So come on, let's go. We're going to look at carbon dioxide, and we're going to look at nitrogen. All right, so step 1 is use your periodic table and find out how many valence electrons you have. So here's carbon. Carbon has 4. There's oxygen. It has 6, but there's 2 of them. So 6 times 2 is 12, plus 4 is 16. All right, step 1, valence electron. Step 2, central atom. Well, that would be my carbon. And then I put my other elements on the other side, so oxygen and oxygen. All right, so we always start out by putting in our bonded pairs. So I'm going to put 2 electrons, or 2 dots, between each of the carbon and oxygens. Well, we've just used 4, right? So we have 12 to go. So we're going to start on the outside, put our dots until we run out of dots to write. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if we look at each oxygen, right, each oxygen has their 8. And this oxygen, right, if we look at this oxygen, it also has 8. So oxygen's totally happy with life. But look at poor carbon, right? Carbon only has 4. Well, it's not happy. But oxygen's like, hey, dude, you know what? I'll give you some more electrons. So each oxygen is actually going to share a pair, right? If it does that, then carbon will also have 8. But oxygen still will have 8. Now, I'm going to rewrite this to show these pairs in the middle. So here's our little central atoms. And now I've just brought this other pair in here, like that. But oxygen still has these 2 pairs out here. And it doesn't matter if we put them on the top or the bottom. But now, if we look at carbon, right, carbon has 8. And each oxygen still has 8. Everybody's happy. Now, of course, we usually write double bonds in terms of dashes instead of dots. So if I really want to do this one up right, we should write it like that. Remember, each dash represents 2 dots or 2 electrons. So here are my 2 double bonds, and here is carbon dioxide. All right, let's take a look at nitrogen. So nitrogen doesn't have a central atom, right? It just has 2 ends. And each nitrogen on the periodic table, right, nitrogen's here in column 5. So 5 times 2 is 10. Well, I already know that I got a problem, right? Because 10 is not 8, nor is it a multiple of 8. And I only have 2 elements here, so I definitely know I'm going to have a multiple bond. But, you know, let's start. We'll put in our bonding pairs. So there's 2, right? I've got 8 more to go. 1, 2, 3, 4, 5, 6, 7, 8. Well, now this nitrogen's happy, right? He's got 8. But that nitrogen only has 4. But you know what? They're equal shares. They're good guys. So this guy is going to actually share 2 of his pairs. Right? If he does that, then they'll both have 8. So if I redraw that using dots, right, I put these 2 pairs in there. So now I have 3 pairs in the middle. And there's my nitrogen. So that guy has 8, right? 2, 4, 6, 8. And that guy has 8. 2, 4, 6, 8. Cool. Everybody has 8. Everybody's happy. Now again, we don't usually leave multiple bonds in dots. So I'm going to change these to dashes. Remember, each dash represents 2 dots, and there is my triple bond, nitrogen. All right, so when you are doing Lewis structures for covalent compounds, just follow the procedures, put all your dots around, and then look, does everybody have 8? If the central atom doesn't have 8, well then somebody's going to have to share some more electrons. So just move them in. As long as everybody has 8 in the end, everybody's happy.
We're also going to have to draw Lewis structures for polyatomic ions.
All right, now it's time for some pesky polyatomic ions. So a polyatomic ion, sulfate, has the chemical formula of SO4 with the charge of -2. Now remember that when something has a negative charge, it's gained electrons. And that's important, right? Because valence electrons are how many dots we put down. So we're going to have to add 2 to the valence electrons from sulfur and oxygen. All right, well, let's look them up. Here's sulfur. It's in column 6. So that's 6 valence electrons. To that, I'm going to add the oxygen, which also has 6, but there's 4. 4 times 6, so that's going to be another 24 electrons. And then I also have to add this charge. These are 2 more electrons. So 24 plus 6 plus 2, that's a total of 32 electrons. Woo, 32 dots. Let's do this. So next I got to determine the central atom. The central atom is going to be my sulfur, right? It's the one I have the least amount of. And then we're going to put the oxygens around it, just like that. There's my 4 oxygens. Next, we put in our bonding pairs. So we put 2 dots in between each of my atoms. So now I've used 2, 4, 6, 8 electrons, which leaves me with 24 electrons left. All right, starting on the outside, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Woo! Wow, I'm tired now. And if we take a look at each of our elements, right, there's sulfur, and sulfur has its 8. Each oxygen has 8. So everybody's happy, but I'm not quite done yet, because remember from when we did the Lewis structures, if there was a charge, right, we have to put brackets around it, and we put the charge on the outside like that. So there is sulfate. Carbonate. The formula for carbonate is CO3 minus 2. All right, step 1, countervalence electrons. Carbon has 4, oxygen has 6, but this time we're going to multiply that by 3. Oops. All right, that's 18, plus 4 is 22, and then we got to add this, right? Oops, I'm saying 22 when I'm writing. I got to add these two, right? So that makes a total of 24 electrons. 18 plus 4, 22, plus another 2, 24. All right, central atom obviously is my carbon, and my oxygens are going to go on the outside. Now, I could have put one up here and not in the other spot. Totally cool, as long as they're around the carbon. That's awesome. And we're going to put in our bonding pairs. So 1, 2, 3, 4, 5, 6. All right, so we just used 6, which means we have 18 left to put around. So starting on the outside, let's just put 18 dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You see the problem? Each of my oxygens has 8, but Mr. Carbon here only has 6. But you know, oxygens, they're friendly. Oxygen's going to share a pair of electrons. And so if I rewrite this, I didn't really give myself a lot of space, did I? We're going to rewrite this so that I have a double bond here. And then of course, let me fill in my outer ones. Now, my carbon has 8. 2, 4, 6, 8. And each oxygen, right, even this guy still has 8. Of course, multiple bonds, let's write them as dashes. And we got to put the brackets and the charge. Don't forget to do that. If it's got a charge, we need brackets and the charge, just like with ionic Lewis structures. So there is my carbonate. I'm going to put in dashes there. Now, who says that it's that guy that shares? Maybe it's him, maybe it's him. Actually, all 3 of them do. And that's what we're going to talk about next with resonance.
Called resonance. So resonance exists in covalent molecules, not ionic, whenever it's possible to draw more than one valid Lewis structure. Who's to say the double bonds on the bottom oxygen? Maybe it's on the top, or maybe it's on the right side, left side. I don't know. It could be any. So anytime there's a double or triple bond, and it could be between one or more of the central atoms, so between any of the carbon and the oxygens, it actually moves around. It doesn't just stay at that one side. Those electrons are moving. And so anytime there's resonance, you need to draw all the possible structures. And we use a symbol, an arrow in between them to show resonance. So for example, for carbonate, we draw all the possible structures. We put brackets and we put arrows in between them. So in carbonate's a great example that there are 3 Lewis structures possible. And really what's happening is all 3 of those carbon-oxygen bonds are equivalent. No one's better than the other. So they're all kind of like somewhere in between a single and double bond, but we can't really draw it that way. So we draw all 3 structures. So we're going to need lots of practice with this, right? So try the Check Your Learning practice on the bottom of the page. And then let's work on some more in class. See you later.